In the area of science and gigantic mysteries, discussions about what existed prior to the enormous explosion have sparked mixed conversations and fascinated thinkers for quite a while. This huge question doesn't just test how we decode the universe, it challenges the actual boundaries of human knowledge. Imagine yourself at the brink of existence, examining the colossus, observing and pondering what existed before our universe was even imagined. The event of the Big Bang marked the beginning of all things, including time and space. But was there a moment before this? Could there have been a state of nothingness, a calm before the cosmic gathering began? And if so, was it truly empty, or did something far more mysterious exist before the dawn of time? As we continue this inquiry, science takes us on a journey that tests our conscious awareness. Physicist Brian Cox, well known for his investigations into the awe-inspiring universe, suggests that something surprising may have existed prior to the massive explosion. He urges us to reconsider our understanding of reality and existence. In this exploration, we will dissect theories, research, and dazzling discoveries that might explain what preceded everything we know. We will investigate ideas such as cosmic inflation, quantum fluctuations, dark energy, and multiverses. The answers we find may leave us astounded, but they could also open new understandings of our place in the cosmos. Prepare to plunge into the depths of the universe, into a realm that defies both imagination and science, where the unknown still lingers in the shadows, leaving scientists both awestruck and, at times, unsettled. To understand what may have existed before the Big Bang, we first need to analyze what the Big Bang itself was. Scientists define it as the moment when the universe, once extremely hot and dense, began expanding rapidly, triggering the formation of all matter, energy, and space itself. When we look at the night sky, we see evidence of this hot beginning, with galaxies still moving outward from an early starting point. But why did this expansion happen? Was there a time before this blazingly fast start? According to the theory of cosmic inflation, there was indeed a period before the Big Bang, but it did not resemble an empty void or a state of peace. Instead, vast expansion suggests that before the Big Bang, the universe was in a cold, empty, and stretched-out state, something like an immense vacuum. However, this vacuum was not truly empty. It contained a tremendous amount of energy that fueled the rapid expansion of space itself. This expansion, called inflation, occurred so quickly that it essentially laid the foundation for everything that followed. During this phase, space expanded at unimaginable speeds before eventually slowing down, converting its energy into matter, particles, and the fundamental forces we now recognize. But what was the nature of this energy? Why did it suddenly trigger the birth of the universe? And why did it stop? Scientists believe that this inflationary expansion created different regions of the universe, each with its own unique properties. Imagine a fabric stretching outward, with tiny bubbles forming within it. Each bubble represents a separate universe, including our own. This concept, known as the inflationary multiverse, suggests that there could be countless Big Bangs and an infinite number of universes. Our own universe may be just one of many in this grand cosmic structure. The idea that nothing existed before the Big Bang is speculative. Even if we remove all energy, particles, and radiation from the universe, it still wouldn't be true emptiness. The void of our universe is filled with quantum fields, dark energy, and other forces that create an intricate cosmic tapestry. Even in what we perceive as emptiness, there is always something present. If we imagine stripping away all these forces, leaving only a truly empty space, the universe would still generate fluctuations. Quantum mechanics suggests that even in a vacuum, energy can momentarily appear and disappear, creating an unsettling echo of movement. This challenges our concept of true nothingness, implying that even before the Big Bang something existed, something that scientists are only beginning to understand. One of the most fascinating cosmological theories is the idea of eternal inflation. If inflation could cause our universe to exist, it suggests that it may have been happening forever. Brian Cox describes an astonishingly vast inflationary multiverse, where universes are continuously created and expanding. Imagine each Big Bang as a spark igniting another universe, while inflation continues in different regions, producing numerous new universes. In theory, this cycle could continue indefinitely. This concept of an endless, self-replicating universe gives rise to the idea of a fractal-like multiverse, where each new universe may create its own Big Bang. Every universe exists as an independent domain, unaffected by others, due to the rapid expansion of space. For researchers, this hypothesis is both exhilarating and daunting. It suggests a multiverse that has no beginning or end. What if the unsettling truth is that there was no before or after? Instead, existence may be part of an eternal pattern of universes evolving continuously. Our understanding of nothingness changes when we consider quantum field theory. According to this theory, the universe is not just an assortment of matter floating in space. Rather, it is a vast, interconnected energy field that fills all of existence. These fields function like invisible oceans, with waves and disturbances manifesting as the particles we observe. Even when these fields reach their lowest energy state, known as the quantum vacuum, they are still active. Particles can momentarily appear and vanish, creating fleeting but measurable effects. This phenomenon, known as quantum fluctuation, suggests that nothingness is never truly empty. In the end, as we venture deeper into the mysteries of what came before the Big Bang, we find ourselves faced with more questions than answers. But perhaps, in the vastness of the cosmos, the search for what existed before time itself will lead us to an even greater understanding of our place in the universe. Imagine a void universe in which nothing exists. Radiation and energy are eliminated. Would you have nothing at all? Quantum field theory says that you would not. Even in a vacuum, fields occasionally engage in transient particle movement in what should be nothing. This suggests that the universe doesn't acknowledge our notion of emptiness. The fields and forces continue to fill the universe with hidden energy that prevents total inertia. This understanding raises an intriguing question. If fields make particles and the universe of particles could make matter, could matter itself have emerged from this void? The universe, filled with dark energy from quantum fields, is driven by an unidentified force that causes its rapid expansion. But did dark energy exist prior to the Big Bang? Certain hypotheses suggest that dark energy is an energy leftover from a field that existed before our universe's development. The properties of dark energy seem to point to a huge secret, a force that might have existed even before the Big Bang. Some hypotheses imply that dark energy existed in a much more powerful state, possibly managing the inflationary phase that resulted in rapid expansion. The presence of dark energy suggests that, regardless of whether our universe were exhausted of all matter and radiation, this force would persist, broadening the scope of spacetime. A troubling question emerges from this thought. If dark energy existed prior to the Big Bang, could it have formed the circumstances that led to the birth of our universe? Could dark energy be the unnoticed creator of inflation or even the true beginning of our universe? As we explore this possibility, we face the potential of dark energy as more than just a force shaping our universe but as a key that could unlock the secrets of the multiverse itself. Another theory that offers an alternative to the Big Bang as the ultimate beginning is cyclic cosmology. The idea that the universe goes through endless cycles of birth, death, and rebirth. In this model, the Big Bang is not a single event but rather a component of a timeless rhythm in which universes expand, then collapse, then regenerate in another cycle. The cyclic universe theory suggests that our universe was possibly reborn from the remnants of a past universe. The process of contraction and expansion in a cyclical pattern would indicate that the Big Bang was merely an end rather than a true beginning. An eternal series of universes may emerge, grow, and renew themselves over and over again. Cyclic cosmology raises significant questions about time, suggesting that time itself might be cyclical rather than linear. If this theory is correct, it could mean that what existed before the Big Bang was just a different universe, one that collapsed only to give birth to our current one. To researchers, this theory offers a rich answer to the question of ultimate origins, that there is no distinct beginning. In some way, the universe has always existed, transcending our ideas of time and existence. Another intriguing concept is gravitational waves, which could provide clues to previous cosmic events. Gravitational waves from the Big Bang are ripples in spacetime caused by massive cosmic events. Scientists believe that detecting early-stage gravitational waves could reveal new understandings of the universe's earliest moments. These waves could serve as echoes of what came before the Big Bang. If identified, they could provide evidence of a pre-existing universe. The discovery of early-stage gravitational waves is one of the most exciting possibilities in cosmology today. It could reveal more than just the truth regarding the Big Bang. It could also provide a glimpse into the cosmic state before our universe was born. This theory offers an enticing prospect, locating gravitational waves that could act as fingerprints from a universe before the Big Bang. As we continue to explore what could have existed since the beginning of time, we investigate ideas that push the boundaries of our understanding, challenging even our most fundamental presumptions regarding space, time, and existence itself. One of the most amazing concepts originates from the realm of quantum gravity, a field that seeks to merge quantum mechanics with general relativity. This merger may or may not expose a single theory of everything but could provide insight into what existed before the Big Bang. According to quantum gravity, time and space are not continuous, smooth entities as we experience them but instead remain hidden in granular structures. This theory posits that the fabric of spacetime itself could have originated from a microscopic structure at the Planck scale, where tiny quantum fluctuations shape the universe in ways we do not yet comprehend. From this perspective, what we perceive as the smooth continuum of space and time might have only emerged from these fluctuating quantum fields. Thus, the state before the Big Bang could be described by a radically different concept of reality, one where space and time themselves were not fully formed. Another possibility is that the universe is part of a vast cosmic landscape of possible universes, each with distinct physical characteristics, laws, and constants. This theory, known as the string landscape, arises from string theory, which holds that all fundamental particles are actually tiny vibrating strings. In this framework, there are many possible configurations, each representing a different set of physical laws. The string landscape suggests that our universe is just one of many, each emerging from its own distinct Big Bang-like event. The existence of such a landscape also brings forth the notion that other universes might have different dimensions, different strengths of gravity, or even various kinds of matter. In this perspective, our universe might not be unique but rather a part of a multiverse, a collection of universes, each independently developing. The multiverse theory offers a hypothetical yet fascinating answer to the question of what existed before the Big Bang. Another universe, arranged in a different way, potentially leading to infinite cycles of creation and destruction with no definitive origin. In addition to these theories, some physicists have also considered the role of black holes in shaping the nature of the universe. A hypothesis gaining traction suggests that our universe may be the result of a black hole formed in another universe. In this scenario, the singularity at the center of a black hole could serve as a gateway to another universe. The Big Bang, then, may have been the moment when such a black hole gave birth to our cosmos. This hypothesis is supported by the fact that, according to general relativity, the singularity at the center of a black hole is a point where space and time curve infinitely, creating a region where the known laws of physics break down. It's possible that the extreme conditions inside black holes may result in the development of new universes. This may suggest that what we consider the Big Bang was merely the birth from the singularity of an ancient black hole. Exploring these concepts requires a deep dive into the nature of time itself. Some cosmologists suggest that time, as we recognize it, might not have had meaning prior to the Big Bang. If the Big Bang marked the beginning of time, then there may have been no before in any standard sense. According to this view, time itself might have emerged from a quantum fluctuation or